Alright, so this video should start to explain ion formation. We've been working with electrons quite a bit. Now we're going to talk about why those electrons are important. I mentioned that they kind of determine all of the chemical behavior of these elements. Why sodium bursts into flames when it's put into oxygen or water, stuff like that. So ions come in many different shapes, forms, stuff like that. Not really. Really, we're looking at, they come with different values. Ions can be positive or they can be negative. Here's how to know how that's going to work. So let's start off. For this, we're only going to work with things in the first two columns, and then probably nitrogen, oxygen, fluorine, chlorine, bromine, maybe sulfur. So, and these are going to involve Lewis structures for the most part. I'm going to show some electron configurations just to explain it a little bit better. Forming ions is going to follow, for today, something called the Octet Rule. Really the rule of 8. Things want to have a full outer shell. For the most part, that's going to mean 8 electrons in that outer shell. So let's look at oxygen. Basic chemical symbol. You look at the column that we wrote in on that paper periodic table, it's in column 6. So let's go ahead and put 6 outer shell electrons around it. So we're going to go 1, and we're going to do the clock method. 2, 3, 4. Now I'm going to double up. 5 and 6. That's mostly visible. Alright, so 6 outer shell electrons. Now the big question, the first question I'm always going to ask is that closer to 0 or is it closer to 8? Because if we can get rid of that shell, we would expose a full shell beneath it, which would make it happy. So 6, closer to 0, closer to 8. Well, I have to get rid of 6 to get to 0, or I can take 2 to get to 8. So let's say we take 2. Let's just say I'm just going to put circles there to show that we take them. Alright, so we took 2 electrons. Now starting off, using the periodic table, oxygen's atomic number is 8. So we know that's 8 protons. Electrons started at 8 because we have 2 in that first shell, 6 in the outer, so that's 8. But then if we've taken 2 electrons, we now have 10 electrons total. So now we have 8 positive protons, 10 negative electrons. They're not balancing out anymore. We're going to have more of one than the other. Excuse me. I have no edit software for that. Alright, 8 positive protons, 10 negative neutrons. So positive 8 plus negative 10. The charge on this atom of oxygen after it takes 2 electrons will be negative 2. So really oxygen forms a charge of negative 2. Now one other thing to note about this is we said that if you're closer to 0 you give away, if you're closer to 8 you take. Because everything wants to look like a noble gas. Oxygen right now looks just like, as I'm doing that wrong, that's alright. If it takes 2 electrons, oxygen looks like neon. If we look at the electron configurations for oxygen and neon, you would go 2s2, 2p6, 2s2, 2p6. Well, let's say that starting off with is 4. Even looking at it this way, we know oxygen is just going to take 2 to go 2s2, 2p6. Because these two are the same then. Everything wants to look like a noble gas. So let's look at the other side of things. So that's a nonmetal. Oxygen takes 2 electrons to get to 8 outer shell from the charge of negative 2. Looking at things on the other end, so looking at, say, let's look at sodium. Sodium, it's in column 1 in your periodic table, 1 outer shell electron. First question I ask is 1 closer to 0 or to 8? I can give away 1, or I'd have to take 7. It's way easier to give away 1. It's a smaller number. The smaller number option tends to be the one you go with. So let's give away that 1 electron. All right, so sodium, periodic table. Only worried about protons and electrons. Starting off with, we were at 11 and 11. What we just said, based on its outer shell, that valence, that Lewis dot structure, we're giving away an electron. So that becomes that. So looking at now, 11 positive protons, 10 negative electrons. If I want to do this algebraically, positive 10, or positive 11, plus a negative 10, leaves me with positive 1. Now, normally in math, you wouldn't have to indicate that it's positive. For charges, we do. For charges, it's important to note if it's negative or positive. You can't just leave it blank and have it be implied it's positive. You have to state it. So in this case, our sodium forms a charge of positive 1. And if we're looking at the electron configuration for sodium there, back on my periodic table, we're going to go shorthand neon 3s2. Sorry, not 2, 3s1. First electron in. We give away that 1s electron in that third shell, and it looks just like neon. Pretty basic. Trying to think, what else do I need to go over? Some other shorthand we can do. Everything in the boron column will form charges of positive 3. Everything in beryllium, positive 2, stuff like that. But it's really important to see this electron configuration thing. Let's see, we can even, I would say it's even important to show it like written out. So normally sodium would be, indicate what I'm doing, 1s2, 2s2, 2p6, 3s1. Afterwards, when we're all done, it'll be 1s2, 2s2, 2p6. It's important to see that electron configuration as well. This way we can see 2 plus 6, that's 8 electrons in its outer shell. For your assignment, what I'm going to have you guys do, electron formation is pretty simple. Let's go through one more, shall we? I'll just go down here. So nitrogen, just straight up nitrogen. If I'm looking at it, 5 outer shell electrons. 1, 2, 3, 4, 5. 5, closer to 0, closer to 8. You could give away 5 to get to 0, or take 3 to get to 8. 3 is my smaller number, so let's go with taking 3. I'm going to signify those with open circles. So nitrogen really, let's go through the whole thing. Alright, so starting off with, nitrogen started with 7 protons. 2 plus 5 is 7 electrons. But we just said we took 3. Let's go ahead and change my 7 on my electrons. 7 plus 3 is 10. 7 positive protons plus 10 negative electrons. Positive 7 plus a negative 10 should give me negative 3. Nitrogen forms a charge of negative 3. Looking at the electron configurations, we have 1s2, 2s2, started with 2p3, but that just changed to 1s2, 2s2, 2p6. Took 3, we're now at 2p6. It now looks just like argon does. So with that, your homework today, I'll have some elements up on Classroom for you guys. Go ahead and figure out the charge, and also shows me how the electron configuration changes. Easy enough. Good luck.